Hi, today we are going to learn about combinations of functions and composite functions. The common terms that we come across when we talk about functions are domain, codomain, and range. Let's have an idea about the domain of a function. Domain of a function is a set of input or argument values that the function is defined. When defining domain, we have to exclude the real numbers that cause division by 0 and real numbers that result in an even root, such as square root of a negative number. And if a function f does not model data or verbal conditions, its domain is the largest set of real numbers for which the value of f of x is a real number. So if a function f does not model data or verbal conditions, its domain is the largest set of real numbers for which the value of f of x is a real number. Let's move to a simple example. So here you need to find the domain of the function f of x is equals to 3 times x divided by x squared minus 25. So let's move to the solution. In this case, as you can see, because the division by 0 is undefined, we should exclude the values that cause the denominator equals to 0 from the domain. So as you can see, x squared minus 25 is the denominator, and we need to find out the values that cause this denominator equals to 0. So in that case, we have the equation x squared minus 25 equals 0, and we are going to find out the values that makes that makes denominator 0. So x equals plus 5 and x equals minus 5 makes the denominator 0. Therefore, we have to exclude minus 5 and plus 5 from the domain of this function. So therefore, the domain is negative infinity to negative 5 union negative 5 to positive 5 union 5 to positive infinity. Let's move to algebra of functions. As we know, a function is an equation that has only one answer for y for every x. As we know, a function is an equation that has only one answer for y for every x. A function gives out exactly one output to each input of a specified type. So let f and g be two functions. So even with functions, we can do addition, subtraction, multiplication, and division. So let's talk about the sum. So the sum of two functions is equals to the summation of those two functions separately. So f of f plus g of x is equals to f of x plus g of x. When it comes to difference, f minus g of x is equals to f of x minus g of x. When it comes to product, f times g of x is equals to f of x times g of x. And when it comes to quotient, f divided by g of x is equals to f of x divided by g of x, where g of x is not equal to 0. So let's move to a simple example. Here we are going to combine two functions. Let f of x is equals to x minus 1 and g of x is equals to x squared plus 4. And we need to find f plus g of x and the domain of f plus g of x. Let's move to solution. So as we know, f plus g of x is equals to f of x plus g of x. So our f of x is x minus 1 and g of x is x squared plus 4. What we have to do is just add x minus 1 and x squared plus 4. Then you can see after simplification x squared plus x plus 3. Now we are in the process of finding the domain of f plus g of x. First we have to find out the domain of f of x. As you can see, the domain of f of x is from negative infinity to positive infinity, because we don't have any concerns about divisible by 0 or the negative roots. So since this does not, the f of x does not have a fraction, we are free to find the domain. So it's from negative infinity to positive infinity, and g of x is also the same. So the domain of g of x is equals to negative infinity to positive infinity, and then therefore the domain of f plus g of x is from negative infinity to positive infinity. Let's move to composition of functions. A composite function can be thought of as a combination of two functions. So a composite function can be thought of as a combination of two functions. Composition of a function f with g is denoted by f composed with g. So this is denoted by f composed with g, and it is defined by f composed of g of x is equals to f of g of x. The domain of the composite function f composed with g is set of all x values such that number 1, x is the domain of g and gx is the domain of f. X is the domain of g and gx is the domain of f. Let's move to a simple example. Here we are going to find out composite functions. Let f of x is equals to x minus 1 and g of x is equals to x squared plus 4, and we need to find out f composed with g of x, and then we need to find the domain of f composed with g of x. So let's move to the solution. We know that from the definition f composed with g of x is equals to f of g of x. Here what we should do is we need to substitute the g of x, which is x squared plus 4, in the place of x in f of x. It is simple as that. What you should do is substitute x squared plus 4 in x or in x minus 1. That's all you have to do. Then when we are going to find the domain of f of x, it's from negative infinity to positive infinity, and domain of g of x is also from negative infinity to positive infinity. Therefore, the domain of the composite function is also from negative infinity to positive infinity. Let's move to another example. So let f of x is equal to 4x minus 1 and g of x is equals to 3x divided by x minus 3. And you need to find a f composed with g of x and then domain of f composed with g of x. Let's move to the solution. As we know from the definition, f composed with g of x is equals to f of g of x. Here what you should do is again substitute g of x in variable which is x in f of x. That is all you have to do. You have to substitute g of x in the place of x in f of x. Then the domain of f composed with g of x is from negative infinity to negative 3 union negative 3 to positive 3 union 3 to infinity. What is the reason for that? Because when it comes to g of x, it is a fraction, and when x is equals to positive 3, then the denominator will equals to 0. Therefore, what we should do is we have to exclude positive 3 from the domain. That is why, but the domain of f of x is just negative infinity to positive infinity, but in case of g of x, the domain is from negative infinity to negative 3, and then from negative 3 to positive 3, and from positive 3 to infinity. Then in this example we are going to write a function as a composition. So here we are going to express h of x as composition of two functions. So our h of x is equals to square root of x squared plus x minus 1. So let's move to solution. So if we take f of x is equals to square root of x, and if we take g of x is equals to x squared plus x minus 1, from the definition we can see that f composed of g of x will equals to h of x, because when you substitute x squared plus x minus 1 in x of f of x, then it will give you h of x.